Hello, good morning. I am Saranya from Hindustan Institute of Technology, Information Technology Department, Coimbatore. I am going to teach you now the operating systems. In operating systems, we are going to see disk scheduling algorithms. Some of the disk scheduling algorithms. First, what is disk scheduling algorithm? Disk scheduling algorithm is a technique used by operating systems to determine the order in which the input-output requests are served for data reading and writing on a hard drive. So its primary goals are to minimize the seek time, which means the time taken for disk arm to move to the desired track, and to improve throughput to enhance overall system efficiency by minimizing the disk arm movement. So the goal here is to minimize the disk arm movement. Okay, we will see some of the common disk scheduling algorithms include first come first serve FCFS, shortest seek time first, that is SSTF, scan, C-scan, look, and C-look. Okay, we will see some of the algorithms, disk scheduling algorithms here. Okay, so first, before that, we will see the characteristics of this scheduling algorithms, and we must know the some common terms before going through the disk scheduling algorithms. First one is seek time. Seek time is the time taken to move the disk arm to the track where the data is located. Okay, the time taken to move the disk arm to the track where data is located. And second one is rotational latency. It is the time taken for the desired sector to rotate under the read or write head. Okay. The time rotational latency, which means the time taken for the desired sector to rotate under read or write head. Transfer time. Third one is transfer time. It is the time taken to actually read or write the data. Okay, next one, response time. The time a request waits before its IO operation starts. It is the time a request waits before its IO operation starts. Next one is average response time. It is the mean waiting time for all the requests. Next one is variance. How much the individual waiting times differ from the average time, right? Okay, now we'll go to the disk scheduling algorithms. Okay, see here, disk access time. Okay, disk access time is the seek time plus rotational latency plus transfer time. Okay, disk response time, which means disk queuing delay and with the disk access time. Okay, next one we'll go to disk scheduling algorithms. First one is first come first serve. Okay, first we will see first come first serve algorithm. It is the simplest disk scheduling algorithms, okay, of all. It processes the requests exactly in order where they arrive. It is simple and fair, but generally inefficient for its performance, lower efficiency. Here, the process request in arrival time, no starvation of requests will be there, and it may result in high seek time and poor performance. Okay, let's see an example for the first come first serve algorithm. Okay, here is the time taken. Okay, from the order of the request is given here, and the current position of read and write head is also given where it is 50. Okay, so we are going to what they said in first come first serve algorithm. In first come first serve algorithm, we the request exactly done in the order where they arrive. Okay, okay, so here the total overhead movement, that is total distance covered by the disk arm, will be equal to the time taken from 50 to 82. See, 50 is the first thing, so next one we will be going to 82. Next we are going for 170. So first we will be reading 50, then we are going to read 82. Okay, after that we need to go to the 170 in the order which they arrive. So the time taken will be 82. The time taken will be 82 minus 50 plus 170 minus 82. Then next, after that 170, we will be going to 43. So 43 distance covered, 140 higher one is okay, higher thing. So 170 minus 43 plus after that 43 we will be going for 140. Okay, the order in which it arrives. Okay, after 140 it will be going, we will be going for 24. After 24 it will, should be going to 16. So after 16 the disk arm should move to 190. Okay, so in the series in which they arrive, it will be we will be calculating the distance covered by the disk arm. So the distance covered will be 82 minus 50, 170 minus 82, then 170 minus 43, then 140 then for 43, okay, then 43 minus 120. Okay, so we will be 140 minus 43. So after 140 it will going to 24. So 140 minus 24. After 24, it is going for 16. So 24 minus 16, then 190 minus 16. Okay, 190 here, 190 minus 16. Larger number minus the smaller number. So the total distance covered here is 642. Okay, next some advantages of FCFS. That is, here some of the advantages are every request gets a fair chance. Okay, every request will be getting its chances. The main disadvantage is performance. Okay, compared to other algorithms, it will be working with lower performance. Okay, next one, shortest seek time first. Shortest seek time first, second algorithm is short SSTF. It selects the request closest to the current disk head position. Okay, we are going to select a request closing that is very close to the current head position. Okay, minimizing the seek time but can cause starvation. Okay, here the main disadvantage will be starvation. Okay, let's see the shortest seek time first algorithm. Okay, with an example. First, the order of request is 82, 170, 43, 140, 24, 16, 19, and the current hit position is 50. So we will be what is the concept here? We are going to select the request that is very closest to the current disk position. So the current disk position is 50. So next closest value to the 50 is 43. So the disk arm will move to 43. Next closest to 43 is 24. Next the arm moves to 24. Next closest to 24 is 16. So the arm moves to 16. After that there is nothing nearby. So after 16, what will be the value we are going to see? Okay, 16. After that it will be going to 82. We have finished 50, 43, 24, 16. So next closest is 82. So the disk arm move to 82 and reads or writes its processes. Then it will be going to 140 and at last 170, and after that 190 will be processed. So here the total overall head movement or total distance covered by the disk arm will be 50 minus 43, 43 plus 43 minus 24 plus 24 minus 16 plus 82 minus 16 plus 140 minus 82 plus 190 minus 170, and at last 190 minus 170, which is equal to 208. Okay. Okay. After that, next one, some advantages of shortest seek time first. The average response time decreases, throughput increases. Here the main problem will be starvation. Okay, as we said earlier, the main problem disadvantage will be starvation. Okay. Next algorithm, scan algorithm. Okay, scan algorithm, it is also known as elevator algorithm. Here the arm moves towards one end serving the request until it reaches the edge and reverses its direction. So what will be here? What is the method here? The arm moves towards one direction, okay, and go to the one end and serves request until it reaches the edge, then reverses its direction. We'll see with the example. Okay, Here is an example for scan algorithm. 82, the head positions are 82, 170, 43 request positions are 140, 24, 16, 190. And read and write now is at 50. Okay. So first they have said, they have mentioned that the discount should move towards the larger value. Okay. Next one, here they said that towards the larger value. Either we can move towards the smaller value or larger value. If they have mentioned, we have to move towards the larger value. Okay. So our head, first our head, arm head is at the um, first our arm is at the 50 position 50. So it moves next to the 82. After 82, it goes to 142. After 142, it goes to 140. After 140, it goes to 170. After 170, it will be going to 190 and it reaches the end, which is 199. After it reaches the end edge, it will be reversing its direction and move towards the next value. So 43 will be next value. After the 24, 16. Here the total overhead movement will be 50. From 50 it is going towards one direction till 199. So 199 minus 50. Then adding with that 199, after that it will be going to the in reverse direction. So 16 minus 199. Okay. So here some advantages are high throughput, low variance, and average response time. Here the disadvantages may be high waiting time. Since reached processes will be in one direction, we will start moving in other direction. So here higher waiting time will be for some requests. Next one, C scan, which is circular scan. It is an improvement over the scan algorithm. Okay, that is advanced scan algorithm, we can say it. Similar to scan, it moves in only one direction. Upon reaching the end, it immediately returns to the beginning after that providing some uniform wait times. Okay, wow. So this car moves in one direction. After reaching the end, it jumps to the beginning and services request in a circular manner, and it provides uniform waiting time compared to the scan algorithm. Okay, here what is the distribution arm read and arm now is at 50. Okay, as it is in scan, we will be going from 50 to 82 in one direction towards the larger value. So 50 to 82, 80 to 143, then 170, then 190. After it reaches the edge, okay, it will come to the beginning, which is 0. Okay, so after it reaches, it goes to the next nearby position, which is 16. After that, 24, and last 43. Right? So the total distance overhead movement covered here will be is calculated as 199 minus 50 plus 199 minus 0 plus 43 minus 0. Okay, the total time will be 391. Okay, some advantages of this are it eliminates starvation, better performance for heavy disk load, and then disadvantages. Some of the disadvantages are extra head movement due to return restart, increased seat time, and more overhead because of the